Hello guys, I'm back with my YouTube channel with a new question on June LeetCode challenge. So today question is cheapest flight within K stops. So let's see what question says. There are n cities connected by m flights. Each flight starts from city U and arrives at V with a price of W. Like 0 is the source and 1 is the destination with a price of 100. Now given all cities and flights together with starting city source and the destination DST. Your task is to find the cheapest flight from source to destination with up to k stops. If there is no such route, then output is -1. So we have to find the cheapest cost within k stops to reach from destination to from source to the destination. So for example, in this example, so we have k stops, maximum k stops. So we can have one stop in this graph, in this route. So the given edges are 0 100, 0 to 1 in price 100, then 1 to 2 in price 100, then 0 to 2 at price 500. So the source is 0 and destination is 2 and up to 1 stops. So basic answer is source to destination is 0 to 2, that is 500, that is given, but we can have one stop. So by stopping at 1 and then going to 2, that costs 0 to 1 as 100, that is this, and 1 to 2 as 100, that total sum up to 200, that is less than 0 to 2. So that is what question says. And another example is we have same graph with stops is equal to 0. So here we can't have any stops. So we have only option to go to directly to 2 in 500 cost. So how can we do that? So let's think about graph algorithms, because we have to travel in shortest path. So shortest finding algorithm, path finding algorithm. So we have Bellman-Ford algorithm, then we have Dijkstra algorithm. So they both can work, but Bellman-Ford have lots high time complexity as compared to Dijkstra. So and we are not having any negative values, so we can use Dijkstra, I think. So what is this Dijkstra algorithm? It is basically the algorithm to find the shortest path from any destination, from any source to any destination. That what solve this question. So first we have to make a graph so that the Dijkstra algorithm can work on it. So how can we make a graph? Then we can easily make a graph with the help of a vector of vector array, in which we can store uh, adjacent, we can store map, we can map source to the destination and the price associated with it. So in this way we can map everything out, and we can have the adjacent, we can have the map itself that can work for our Dijkstra algorithm. So like in this in this example, at the first example, that is this, let's see what graphs look like. So we have edges 0 to 1 as 100. So as I said, I have to make one map from source to the destination and price associated with it, like 0 maps to 1 and 100. First 1 and 100, that is this. Then again 0 is come up with this, so we can map, we can add this also. In this way we are creating a graph. Then also for 1, 2 and 100, the destination is 2 and the price associated with it is 100. Then we add this to our vector. Then 2, so there is no destination from 2, so it is just an empty array, or we cannot, we just not add anything about it. So in this way we can form a graph. So let's see in code how can we form a graph. So maximum size of this graph, of this vector of vector is n, because you see the maximum number of vertices is at most n. So that is this for auto. So now we have to add a map 0 to the destination and price associated with it. Adjacent of 0, sorry, f of 0, then push back both destination, and destination is f of 1 and the price associated with it is f of 2. In this way we have now we have created our graph. So now what we can do is to use it. The Dijkstra algorithm is basically the BFS algorithm. So we are going through level by level, and at every level I am using priority queue instead of queue for a better approach and a better complexity. So in this way we are exploring every level, and at that level in which we reach our destination, then we just have to return our current price. So first we have to implement our priority queue, in which that is basically a min heap in which the top of the element is the minimum of that layer. So in this way I am using the priority queue for a better compatibility of this shortest path algorithm. So let's see what we can do with it. So as I said, we have to first implement our priority queue. So in C++, we can use it by STL. It is a basic implementation of min heap in our in C++. So I need to add the three things in this priority queue. First, the price, in which it is the deciding factor of the min heap, in which it is going to sort in the minimum order. In C++, the queue is sorted as in compare to with respect to the first element of the array. So that's why I am putting the first element as the price, then second element as the source, and the third element is the number of stops left with us. So in this way we can we can obtain our answer. So for the source, the price is 0 always. Then k plus 1, because I'm adding from the source. So source is the k plus 1 stop always. So now it's a regular BFS algorithm. So first, what is the price? So price is the first object, first element of this vector, that is current of 0. Then current source. What is the current source? That is current of 1. Then the number of stops left, that is current of 2. So now we have to check if destination is equal to source or not. If source is equal to destination, current source is equal to destination, we just have to return our price, because this is the price, this is the cost we needed. We have to return for this answer, cheapest price for this answer. So if is equal to dst, then we just have to return the current cost price. Now we have to add the adjacent element of the current source so that we can find the answer. So if number of stops left, oh sorry, stops left is is greater than 0, then only we can have this condition and we can add the remaining element. Adjacent of current source. So now we are adding the adjacent of every element of the current source in our map, that is in our present in our app. So first I have to add price with the Second one is the price of the object. So price with the second one of this vector. Sorry about it. Then second is the source, that is v of first, because this destination becomes the source of next layer. V dot first, then the current stops left. That should be it. And at last, if we can't find any cheapest cost, then there is no way to go from source to destination. Thus we can return -1 as per constant says. Output -1. So let's see this code works or not. 200. So this is it. Okay. So in this question, basically we are traveling every stops, and I'm uh, I'm saying if the current cost from source to destination is greater or not, with the help of min heap. So in this way, min heap is used in Dijkstra algorithm instead of queue. So Dijkstra algorithm is basically a BFS with the help of queue, priority queue instead of queue, which can be used for finding so lowest cost from any source to destination. Thank you. Hope you find this video helpful. Like and comment, and don't forget to subscribe. Thank you.